What's up, nerds?
Let's go.
Well, Yvonne, we're here after the developer keynote. We presented a demo. We call it internally Demo 2.
Demo 2, yes.
Yeah.
It was such a great experience. How do you feel the day after?
I feel good. My voice is a little raw. I did not anticipate the consequences of my actions when I colored my hair this bright color. I knew it would look good on stage, but what I didn't know was that I would become instantly recognizable to everyone in the conference.
Yeah, it happened to me as well. A lot of people, they meet me on the floor and they were asking, oh, that was a cool demo. How do you build that? Great delivery, all this kind of thing. It was pretty nice.
Yeah, maybe we should get into that. So for people who don't know, I'm a developer advocate at Google Cloud. My name is Casey West.
Hi, everyone. I'm Ivan Ardini, same role of Casey on the AI part.
Right. And so we delivered a demo that included a multi-agent architecture, real-time evaluation, A2A, and A2UI, agent registry, a lot of things. But maybe we can go through each of these things and a little bit of how we built it.
Yeah. I mean, I will say that it was a long journey, right? We started building this demo, I think, in February. The initial part was kind of figuring it out, like not only the scope of the demo, but how to combine those services in a way that, we can leverage all the capabilities that they provide. And I think for me, the most exciting part was, designing, thinking about, hey, how we can combine these agents, and for each agent, what kind of capabilities we want to enable. So I remember, we start using tools, and then we switch, and we decide to differentiate between tools and skills.
Even pulling back a little bit more than that, I know that when we were thinking about the concept of planning a marathon and introducing additional agents beyond just a planner agent, I know you and I started thinking about what are all of the, identities that have to go into planning a marathon in a big city like Las Vegas. And so, we initially had thought maybe we'll have half a dozen agents that will all work together.
Yes, exactly.
And they'll all have different jobs, right? But sometimes, that sounds like a good idea. And then we get into implementation and we realize a few things, including the unnatural constraints of a keynote presentation, which is very tight on time. The more agents you have, the more network connectivity and latency you have, it can slow things down.
Yeah. No, I remember the initial prototype that we got. It was running perfectly, but it was taking so long to produce the output that we were expecting, right? So that's when we start considering, okay, we cannot have thousands of agents running in the backend. We need to squeeze them, and for sure, at some point, we figured out that it was not just about the number of agents, but it was about the single component that each agent has, and as well as how we can optimize the communication between the backend, the agentic backend that we build with the front end that yesterday we showed.
Right, and so we ended up settling on a 3-agent architecture, the simulator, the planner, the evaluator. Something that I think is kind of fascinating to dig into a little more would be the evaluation process. Why would we want to have a separate agent for the evaluator when, in our case, the evaluator was only used by the planner agent?
I think, if you remember, when we start designing the system, we were discussing this idea of the agent as a judge that will allow us, to iterate on the evaluation itself. And actually is one of the patterns that is kind of, I don't want to say that it's common out there, but is a possibility that people are exploring. So I think that's where it came in, and we start experimenting with it. And we start thinking, okay, how we can integrate this pattern in the entire agentic multi-agent system that we were building.
Right, and another big piece of it is making sure that we've got essentially a different model grading the results or the generation of one model. So in our case, if we use Gemini 3 Flash to generate a plan, how can we have confidence it's a good plan or it's an accurate plan? we use an evaluation and we do it in real time, but we also use an alternative model, in our case, Gemini 3.1 Pro.
Yeah, correct. Yeah, and this is because, I mean, we want to avoid some biases that, using the same model will inject in the system. So that was a kind of a great conversation, I remember, about the evaluation part. The other one that I really enjoyed, as I was saying before, was at some point we had to figure it out. Okay, should this functionality that we want the agent use be a skill or a tool? Right. And that was a kind of a big moment, I remember. We had to reiterate and change completely. So I think that would be interesting, like to discuss.
Yeah, and it can tie in a little bit, for example, to the A2UI components or agent to user interface, where we had multiple agents in the system that could emit A2UI as part of their generation. And so the way we built that was through the use of skills. So we have a skill that we gave to every agent that needs to do A2UI that explained how to be essentially an expert at A2UI. Using the default catalog. And if you look into A2UI, that's essentially a list of around 18 default components. So it's things like a text, a bunch of form fields, modals, things like that, images, video. And so that allowed an agent to know how to do A2UI. And then I also bundled in a tool with that skill. So the skill can be a prompt, additional prompt and instructions, and it can also bundle tools. So I bundled a tool to validate emitted or generated A2UI. And it's kind of similar to evaluation, where I want to check the results because the agent emits a JSON payload that describes the UI that it wants. And of course, a UI or client, a front end, has to render that. So we want to make sure that we're giving it valid A2UI. So I also have a tool to do that validation.
And yeah, and I mean, as we are saying, like this topic of evaluation, like it's recurrent while you are building, multi-agent system. And in fact, like also here on the floor, one of the most common questions that I received was, hey, but you build such a great multi-agent system, but how do you evaluate it? Like, how do you like be sure that those results are aligned with what you expect, and in particular, they make the system stable. So, I mean, if one thing that I take home from building this keynote demo, for sure, is that evaluation is not just a one-time thing, but it's something that is recurrent while you are building the entire agent system.
In our case, with the evaluation that we built into the evaluator subagent that went into the planner, we also connected it to the evaluation service on Gemini Enterprise Agent Platform.
Yes.
New names, always getting used to them. And that allows us to track our results over time as well. So you can get the real-time evaluation, but you can also have ongoing data about the quality of your agent and what it produces.
Yeah, for people that don't know the services, essentially it's a managed services that provides you an API with a bunch of metrics that are pre-built, but the services is pretty open, so you can customize your metrics. So what we did with Casey, essentially we combine like a subset of custom metrics with some metrics that were pre-built, so we could speed up the process of evaluating an agent. So I think for sure evaluation is one of the key things that we had to consider while we were building. Another thing that for me was fascinating is that I mean, A2A is a great protocol, and I don't think we had many problems on connecting and using A2A in order to build a multi-agent system. But what I remember is that once we got the initial prototype of the multi-agent system, it was working, it was running, but it was taking too long. And this is kind of the moment where I personally realized, this is the difference between building a multi-agent system that kind of works with something that actually needs to perform and needs to be processed, for example, a task in a certain amount of time. And so that's when you start thinking, or even, okay, we have the backend, but we need to find a way to optimize it.
Right.
And I know that you spent a considerable amount of time to optimize it in a way that was fitting with the front end.
I did. So a couple of things that are worth considering. One of them, even just starting with evaluation, but then moving on, is we started with around 7 different types of criteria we were evaluating, and we were making different calls to the Gemini model we were using for evaluation for each criteria. That's nice to keep independent context and keep things really focused. But of course, when you're trying to, when you have a speed constraint, and you have a latency constraint, you have to optimize that a little bit. So we decided to bring all the non-deterministic criteria checks into one call. And of course, using Gemini 3.1 Pro, very capable of being able to handle that, manage, and focus. So that was good. We also, the marathon plan that we generated wasn't massive. It wasn't, a widespread sort of needle in a haystack problem. So it was able to focus and give us good results. A couple of other things that we did, though, these are just little tweaks that aren't always on by default. So, omitting streaming server-side events helps with the perception. That was a big one. That's available, and you can do that on Agent Engine. You can do that if you deploy to Cloud Run, Agent Runtime, or if you deploy to Cloud Run. So that is really helpful also for perception. Trying to think about what else. There's one trick that's actually a little beyond our demo, and this is a little bit behind the scenes, but I built a lot of, excuse me, I built a lot of the simulation that we actually saw on stage, the sort of end-to-end picture. A2A as a protocol is something that I think we should dig into a little bit more. We mentioned the agent card, but the agent card helps expose the agent's description and name. You can expose what types of skills the agent has, and also capabilities. And those capabilities can include sort of technical capabilities. So the runner agents that were in the simulation were in our demo. Excuse me, voice is a little raw, just a moment.
These are the live.
I had to talk to a lot of people.
Exactly.
Yeah, I'm working on it. But the runner agents in the simulation were, we had to do 1,000 sessions. I mean, sure.
Yeah.
I was ready to go. But
Yeah,
it's okay. I'm like, we'll fix it in post, right?
It can be.
Now we'll keep going.
Yeah,
So in the simulation that we saw on stage, the runner agents, we had to spin up a number of them and have 1,000 different runner sessions happening at the same time. So all those little dots we saw on the screen were a single session on an ADK based agent that could speak A2A. But in order to do that, where we can instantly send 1,000 sessions a message and have the agents respond, and collect data about the agents, so their velocity, their hydration levels, that sort of thing. I had to route A2A over a pub sub using memory store. So what I did was, A2A is an extensible protocol. So I extended the agent for the runners to have a different callable mechanism. So it could be callable over a standard HTTP call, like most A2A agents will be, or you could call it by sending it a pub sub message. And so I just used the protocol to inform other agents and system components about how to call each type of agent. So it wasn't hard-coded. So if we were calling the planner agent, we used HTTP A2A. And if we were calling the runner agent, we used pub sub.
Yeah, no, this is pretty cool. And when you show me this kind of integration between the front end and the back end, as I told you also yesterday, it reminds me a lot of, kind of the architecture that is behind OpenClaw, but scaled it using native Google Cloud or cloud products, which I was so excited about because it allows us to kind of seeing in action like a system that is inspired by OpenClaw, but at that scale and presenting it as we did yesterday was just very, very exciting.
Yeah, I'm a big fan that when there's an open source project that is something, near my type of work, whether it's a Google product or not, I want to dig into it and break it apart. And I definitely took some inspiration from models or systems like OpenClaw. They have a standard gateway for message passing that allows them to have multiple front ends that the agent can be agnostic to. And then on the other side, it's essentially like a mesh network or a mesh system for agent-to-agent communication. And so that's what we built into the simulation as well. All of the agents could actually speak to each other. There's sort of communication pathways that were built into the agents using prompting, of course, but every agent had the ability to communicate with every other agent.
No, it's pretty cool. And, adopting this kind of, again, pattern or architecture, like we were able to optimize. Just as a disclaimer, we had to do that because we had restricted amount of time to run and show the capability of the system. Like, of course, for people that, they want to build a multi-agent system, this is not required maybe, but for sure, it would be great, the code is public, right? So it would be great if you go there, check what we build in that sense.
One of the things that I get asked a lot is how do you trust the output of a model? You have tools that say go and get data from your trusted data sources, and then they go through a model and the model emits that information. How do you know it wasn't hallucinated? How do you know it hadn't been modified? And of course, that was a similar problem that we had to contend with in the simulation. So on the subject of optimizations, ADK as a framework is very extensible and pluggable. ADK has a concept of plugins, and those plugins allow you to hook into the event lifecycle of an agent or of a multi-agent architecture entirely. So we also wrote a plugin that hooked into the lifecycle and emitted events, again over PubSub, during the agent's execution. Those events went to a gateway, so that's where the OpenClaw model of communication was an inspiration. And then the front-end simulation listens over a WebSocket for protos coming over that WebSocket for every event in the lifecycle. So that was also how we could expose the inner workings of the agents to the client. But it's also a pretty valuable technique where if you know that you're going to have a tool call that returns trusted data, you can also use event callbacks or plugins in ADK in order to even expose that data right from the tool to your clients or to other dependencies in your system that need to have guarantees that the data is exactly what you want it to be.
Yeah, I mean, playing with protos, it can be a little bit hard, but that
we were trying to optimize.
These are the situations where you can see the value of a technology that maybe requires a little bit of ramping up, but it provides performance.
Yeah, so imagine if you had 1,000 agent sessions all sending a message simultaneously, and you need to get that over a WebSocket to a JavaScript front end in the browser. Yeah. That's what we did. So how can we optimize that? Well, we're going to use protos, and we're going to really tighten it down.
It makes a lot of sense. Before to wrap up, one other thing that I want briefly touch is for sure related to the governance, right? So in our case, at the end of the day, we had 3 agents, right? But in the case of building a very large multi-agent system, at some point we were discussing about, hey, how do you govern this system? How people that they don't know anything about the system that you build as a developer, let's assume inside the company, how these people can have a quick picture of the system itself. And so that's when we decided to introduce the agent registry. So I think it's a valuable component of our system.
Yeah, and along with the registry, other demos talked about Agent Gateway, and that's a way to make sure that you have tight controls over data access, service access, and agent access.
Yeah,
so that's good.
And something that maybe we didn't touch during the demo because all of them, they were mainly deployed on the agent runtime. but the agent registry really provides like a 360 overview of the agents that you deployed on cloud. Right. So it's compatible with other services.
Well, if people want to get their hands dirty with this, if they want to get into it, we've written a code lab.
Yes,
Admit that Yvonne did most of the heavy lifting on that code lab. So where can they find it? Look in the camera and let them know.
Yeah, exactly. So essentially, we published the collab on our collab platform. Yesterday, we shared the QR code. I think we will share the link in this video. You can find it in the comment. So, but yeah, I hope you will have time to experiment with it and provide us feedback if you really enjoyed it.
Sounds great. Thanks, everybody.
Thank you, everybody.